Okay, hello everyone. My name is Roman Ivantsov, and I'm here as Irony project coordinator. Irony.NET language implementation kit. A year later, some of you who have been here a year ago remember my presentation. It was just the start of the project. So what happened during this year? Okay, I won't run any any demos here. I'll just talk and show slides. Irony, all in C#. For language implementation, something like Yak, whatever, everything in C#. No code generation. And for grammar specifying just embedded DSL using operator overloading in C#. LAR parser, just like Yak, whatever, provides some tools for grammar debugging and testing and scanner construction, no regular expression, none of this stuff, purely object-oriented architecture. Provides some script runtime for script execution, simple scripts. It's just a draft, just the start. Here's the example. I'm not sure if you can see this, how you specify the grammar. You inherit the grammar class, you define the local variables, first terminals, which are just instances of predefined classes, then non-terminals, you name them, then you specify the BNF rules using overloaded operators, and you are done. You assign the root is my program element, and that's it. It's your grammar. Then you run, instantiate the parser provided with the grammar instance, and then you get the parser. You are ready to parse the program. So why use it? What is so good, I think, about Irony? And I think lots of things good, and it's really can be attractive to both professional compiler development and for people who are not very much into grammars, parsing, and so on, and just want to do their little DSL. It's easy to start, easy to write the grammar, easy to debug, easy to maintain. Just a few seconds, if you make changes to the grammar, a few seconds, and you're already parsing with it. It's fast, which is probably important for professional compiler development. It's really, really very fast. And it's fast because of its scanner implementation, as probably people in this area know that most of the time the parser scanner spends in scanning. Probably 80% of the time. So all your speed of your implementation depends on the implementation of the scanner. And for Irony, it's done in such a way that it allows you very, very fast scanning. So the speed is more than 10,000 lines per second for languages like C#. And one user reported 10-fold speed improvement after moving from Goat parser-based solution. It took him just 2 hours to transliterate the grammar, and then he got 10 times performance boost. And all of this because of the scanner architecture, basically. Scanner features, in addition to performance, is really flexible. We probably all know that scanning is simple when we talk about just numbers and some simple strings, but real-world languages, they have all these additional options, prefixes, suffixes, and so on, and implementation of these things is a real pain in all parts of the body. So actually, Irony provides the predefined terminals, which are very, very configurable, and I give you a couple of examples how you can configure a number literal for implement C# number with all the suffixes, hex suffix with all the predefined types that it supports, and all suffix codes. And another is string for Visual Basic with 2 suffixes that can specify optionally. And even if you use these facilities, the main thing is that it doesn't make your scanner or compiler slower, because the terminals, they always use the fast path. So if it's simple, if it's just 1, 2, 3, then it's number, boom, we are out. If not, if it means something suspicious, then it goes the full path. What's new? And I think compared to other solutions, it's I'm trying to come up with some new parsing method, and LRT It's non-canonical LAR with some grammar transformations, and I will just very, very quickly speak about this. It's a very common problem, and actually standard problem in LAR parsing, the parser conflict, reduce, or shift-reduce conflicts. So let's say we have some very simplified language in which we can define fields, methods, and properties. They all start with some modifier, then type name, and then the name, and then something that actually identifies it. It's property, field, or method. So it's a very common situation in C family of languages when you have lots of stuff, and you're not sure what you're actually parsing until you get to the end of the sentence. And when you start to implement, and the problem with the modifier is that some modifiers are common, like public for all three statements types, and some are specific. So when you start to implement the grammar, naturally you define field modifier as a list of modifiers, method modifier, and property modifier, and boom, you did all this, and then suddenly parser runs into the conflict. So when he reads the public, what is that? He doesn't know. So, and the only information he has is the single ID, and he needs to know what lies ahead. So, and in practice, the parsers implement the preview, some special custom preview mechanism, run ahead and see what comes first, and so on. This requires it's quite painful, and especially for people who you need to know the tool, the implementation, and so on very well to do this. So the idea is, what can we do about this? How can we fix the parser? And the idea is that first of all, switch to non-canonical parsing, and non-canonical means that look-ahead tokens for the parser can be terminals and non-terminals as well. So what we can do is we can start with parsing the first element, field modifier. If we cannot decide, we can go ahead and parse the next element, and then come back and decide. In this case, we need to transform the grammar and wrap the tail of our productions into the tails. So field definition becomes field modifier and field tail. So we transform the grammar, and then it becomes suitable for non-canonical parsing. And the trick is that actually the tail wrapping can be done automatically by irony. So that's the new method. And the ultimate goal is to create a parsing method that actually is free from these limitations, very annoying limitations of LAR parsers. It's still in active research. It's not out. We are able already to parse this simple grammar, but it doesn't work yet well for big and complex and very grammars with a lot of conflicts and optional elements like C#. Projects using irony, it starts to take off. One of the things, so the book about full text search, they use example, provide an example of conversion of Google-like query into SQL query for providing full text search capabilities, and they use irony for the conversion of the queries. Now we heard the talk today already about the language service. So for irony, there is already implementation of language service wizard. So actually, it's application that you run. You specify what's your grammar, blah blah blah, and you get your language service integrated in the Visual Studio with all the, not all, but most of the tweaks. And it was done by Ben Morrison. There is an article in Code Project about this. Some other things, there is script.NET scripting language implemented on irony. There is a Lua language support in Visual Studio, also based on this language service. There's some mixing irony with DLR attempts, expression evaluator, and some DSO implementations in-house. So, invitation for collaboration. Certainly will appreciate any help. In areas I want to extend it into the middle tier of the compiler to data flow analysis, control flow analysis, and need help in implementing some special algorithms in parsing, and language implementations are welcome. I also want to ask whoever is here is from academic community, from colleges. I think irony is a perfect playground for students' work. It's available there. It's simple to use, and for computer science courses, it's just a perfect place to be. So we have students wandering around, killing time before graduation, then just put them here and let them do some productive work. And contact me at CodePlex. That's it. Thank you. Any questions?
I saw your grammar there. Where does semantic information come in? I saw your grammar had like ID, semicolon for when production.
You mean semantic? What does it mean? So essentially, it's expression evaluator, and it can evaluate expressions. So this is grammar, which actually builds abstract syntax tree. The nodes in the tree, you can actually specify for non-terminals. There are types. You specify the types of the nodes to create. And so these nodes, they are actually also provided by Irony. It's some very basic implementation of AST trees. And they can evaluate the expressions. And there is a dynamic operator dispatch, so based on type, something like mini micro DLR thing. So that's semantics.
So I see you've got language server support. So how do you deal with incremental parsing? Do you have any general solution for that? Or
For what?
Incremental parsing. Dealing with just a small change that you've made to the file as you type. Compiling as you type.
It's just basically it's the same. It relies on Visual Studio. It actually calls you repeatedly, asking to reevaluate, reparse, rescan the code. So essentially, it's important that your grammar implements a good recovery mechanism because it's partially correct. So, and you can actually, there is an error rule you can specify on non-terminals how to recover. For example, for statement, you say, just skip everything until closing brace.
Do you reparse the entire file every time? Or?
Well, it depends on how Visual Studio wants it. It's actually, it's not our solution. But basically, yes, and quite huge file, it's a fraction of a second. And Irony actually has the Grammar Explorer that I provide. It has the syntax-colored editor based on rich text box, which is famous for unsuitability for things like this. But it works quite well there. And actually, Irony, it's not even Irony, the bottleneck. It parses the huge files in tenths of a second. As I said, it's very fast. It's how the coloring works in the editor. That's the main problem. But I originally thought that probably I can try to parse part of the file, but then it's just not worth it. As for scanning, it's so fast. I can scan huge files repeatedly, every second, several times. No more questions? Yes?
You have to specify recursive rules explicitly. Is that right?
Yeah, it's like in LR kind of grammars, left recursion is allowed. Yeah. And for lists, there is a special methods that allow you to avoid all this nesting that happens if you literally interpret the rules. So there is a make plus rule. I think I have somewhere here. Yeah, make star rule. It's when I have program as a list of statements. So it actually creates this star rule. Actually, the list program is a list of program lines, and when it generates the actual tree, it doesn't nest multiple program into each other. It creates a nice and clean, plain list. Thank you.